Tomorrow.
Okay, number 2 is solving an equation for x. Okay, the directions say solve the equation square root of x plus 8 equals 2 and describe the steps. When you solve radicals, you must check your solutions. Boy, you would really be awesome right there. And if you did y'all, I don't know if you looked at the quiz stars, but one of the ways I figured out a way to make this written response a little bit more comfortable for you is if y'all do that vocabulary. Go to your quiz stars, and it's called vocab 1, 2, 3, or 1 through 3, I think it is. Did you try it? Try it a couple times because I'll give you that, and then I'll say, okay, what I can do to justify what I'm doing is I can say, okay, another vocabulary. You guys might not be comfortable using it yet, but you're on your way. If you make a 20 on that vocabulary test, and then this is not very, you see what I'm saying? I'm trying to give you okay, so this problem is square root of x plus 7 plus 8 equals 2. So in this problem, obviously, to solve this equation, you need to, what would be a good, get a square root by itself, get a variable by itself, set it up equal to, use those kind of terms right there. Isolate, boy, what a word, isolate the square root. Okay, it says plus 8, so it's a plus 8, so if I want to do a plus 8, don't just do this for your explanation. That's what a lot of us did the other day, is we had an equation that we had to solve. Now, we're not going to have any like this, I don't think. But we had this equation that we'll solve, and you subtract the equation, and then that was it. There was no work. That's all there was the work. What I'm trying to do is, if that was a minus 8, make sure to solve an equation to add or subtract you got to add or subtract the what? The same number? Like if that's a plus 8, do you add 8? Or is it plus 8?
No, you subtract.
So add or subtract the opposite. Now all of a sudden you used a math term. Underline it. Make it do something here and make it important. So I know that you know if these numbers changed, you'd still be able to solve the equation. In this problem, it causes your solution to be no real numbers, because there's no such thing as a square root equals a negative. That doesn't work. It doesn't work. The square root of x plus 7 is never going to be equal to negative 6. Okay? If it were, and you got rid of the square root, well, how do you get rid of multiplication? You divide. How do you get rid of addition? You subtract. How do you get rid of a square root? You square something. Let's say down here, let's say something about if this wasn't a square root equal to a negative, and you kept solving the problem, you get x plus 7 equals 36, so x equals 29. Okay? Next page. If x equals 29 is my final solution, then when I took the equation 29 plus 7 plus 8 equals 2, should be a true statement. But look, it's not. Square root of 36 is 6 plus 8 is not equal to 2. Therefore, there is no solution. How do you know that? Because the solution should work. It should give you back the right answer. When you plug it in, okay, this was a linear equations problem. What might be something that you would say? You would say add and subtract the opposite. Maybe you have to distribute. I use the distributive property to, okay, so out here, the distributive property, you might explain the distributive property. I use the distributive property. Do a little footnote. Put a little 1 up there. Come down here and 1. Distributive, and explain how the distributive property works. A times B plus C is AB plus AC. And so you explained distributive property. You didn't just do it. The other day, a lot of times, Joe just started working problems out and there was no explanation. But then when we did explain it, we followed these ABCDs too much. Realize that if you do the ABCD, what you'll do is you'll explain the ABCD. Inside the explanation. You don't have to list it out. Sometimes that's the only you can do. There's other methods of doing the explain. 33 and 34 are two problems that you're asked to factor in. The leading coefficient of these problems, the phrase the leading coefficient means the coefficient of the first term. Okay, what it is in this problem that lets you know how you do these problems is because it has a leading coefficient of 1. So 33 and 34 are both examples of problems that have leading coefficients of 1. And when that's the case, the way you know how to solve these problems is by looking at the C term, the third term, the constant sitting out there by itself, and asking yourself, what are the factors of the last term that I add together to give you the middle term? I saw this online last night as I was watching some videos and trying to figure out how I could help you guys out some. Some people will list those out. They'll list the actual factors of 5 out, almost like an ordered paper, if you will. They'll say one of the factors of 5 is 5 and 1. Another factor, well, it turns out that's the only thing that you have a choice for in factors of 5 that have given you 6. So in this problem, you take this C sitting out there by itself because the leading coefficient is 1. You ask yourself, what are the factors of 5 that have given you 6? So it's x plus 1 times x plus 5. Next video, I'll put an equals 0 out here on the end, and then we'll have to understand that if it's equal to 0, we have to solve it on down and say x equals the opposite of each of these things. But that's not the case here. We simply have a leading coefficient of 1 and the factors of 63. So if I want to take the factors of 63 and write them out, we're going to start at 1 and 63, 3 and 21. Eventually I'll get to 9 and 7. That's the factors that I'm looking for, because 9 times 7 is 63. And negative 9 plus a negative 7 is negative 16. So my factors of 63 that add together and give me 16 are x minus 9 and x minus 7. Once again, that's my final answer, because x times x is x squared, negative 7x and negative 7x. Those two terms add together to give me negative 16x. And if you remember just a second ago, that's what I said, well, the factors are 9 times 7, the factors of 63, whose sum is negative 16. And then again, I stop right here because it's not equal to 0. If I look on ahead, just take a quick sneak ahead at numbers 37 through 39. I notice that those are all set up equal to 0. Or if they're not set up equal to 0, that's the first thing you have to do to them. You have a quiz star, there's one of your quiz stars that's solving for x. That's a linear equation. You just get your numbers on one side, variables on the other. Then there's another one that's solve for x by factoring. When you have to solve for x by factoring, after you get your factors, after you've got what you think the answers are, let's say, and answers here, A plus B and C plus D, you set each of those factors, whatever they are, right? A plus B equals 0, C plus D equals 0, and then solve each of those equations for whatever variable you have in the problem, like x, or x squared you're solving for x, or y squared you're solving for y. In this case, I don't have a variable there, so maybe I need to solve this for A. So A would be equal to negative B, and C would be equal to negative D. It's called solving that equation. The reason I need to solve it is because it has equal 0 in it. 33 and 34 don't. So you simply got to stop when you have the problem factored out. Which also leads to the way that you can check these is by multiplying out and make sure it gives you what we started with.